Three mutually tangent spheres of radius 1 rest on a horizontal plane. A sphere of radius 2 rests on them. What is the distance from the plane to the top of the larger sphere? So this is the kind of situation we have. The only difference is that in our question, the three spheres that are on the bottom definitely would look something like that. And each of them has a radius of 1, so they're all equal. Now the sphere that's placed on top of them in this diagram is also equal, right? But in our question, it's not. It's a much bigger sphere. It's basically double the radius. But that's not a problem. It's not going to affect our diagram. Our diagram that we have here is going to help us regardless of what the radius values are. So first I want you to look at this initial diagram right here. Those dots right here, right here, right here represent the centers of those spheres. And when you join them, they form an equilateral triangle, correct? And that equilateral triangle basically has side length of what in terms of numbers? Well, the radius of each sphere is 1. So if you draw a line from the center of one to another, that's 2 radii. So each of those sides will be 2, like that. Sides of the equilateral triangle. Now what you do is you draw a diagram like this, which represents that sphere that's placed on top. And they want you to figure out the distance from the top all the way down to the bottom, like that. Well, how do you do that? You split it up into 3 segments. The first segment is from the middle of the top sphere to the very top, like that. The next is from the middle of one of the bottom spheres to the bottom, like that. And then the last component is going to be the one that we concentrate on the most in this question, which is from the middle of the top sphere down to the base of that triangle. Okay? Like that. Now, if we do that and we add up those 3, that will be the height of the total figure. Now, it takes a little bit of visualization. I know it doesn't look exactly like you think because this is 3D. You've got to basically visualize this in 3D. Now, the good news is the first one, which is from here to here, that's straightforward. That is the radius of the big circle. So that is equal to 2, as they state in the question. The next one, which is from here to here, basically it's from the base of that triangle, this triangle, from that triangle to the bottom, is the radius of one of the smaller spheres on the bottom, and that's 1. So this guy is equal to 1. And now we just have to concentrate on this one in the middle here, and that basically represents the distance from the center of the top sphere to the base of that equilateral triangle. Okay? And that one I'll call it H. So when I'm done, my total height from top to bottom of this figure will be this guy here, which is 2, plus my H, plus that one right there, 1. So it'll be 3 plus H. And you can see some of the answer choices, they're already in that form, 3 plus something. Almost all of them except this one. Well, perhaps that's 3 plus something also, maybe. All right, no problem. Let's proceed with, the only thing we need to proceed with really is finding H. Now, to find H, how do I proceed there? What's the trick? What's the magic? Well, first and foremost, I'm going to draw one line from the bottom of H to one of the corners right here, like that. That creates a right triangle right here. Okay? And that is the triangle I'm going to work on. but I'm going to draw it here because the diagram is getting kind of messy here. So that triangle I'm going to draw right here. Now this top to bottom was h. How about this hypotenuse here? What is that? The good news is we know that. It's the distance from the center of the top sphere to the center of one of these smaller spheres. So that basically means it's just the two radii. When you draw a line from the center of the top sphere to the center of the bottom sphere and connect them, it'll be equal to 2 times the radii. The radii of the top sphere, which is 2, and the radii of one of the bottom sphere, which is 1. So this will be 2 plus 1, like that, which is equal to 3. And now I just need to figure out this side right here, x. If I can figure that out, I'm set. I can figure out h, and then I'm done with the question. To do that, I have to concentrate on this equilateral triangle. And I'm going to draw that equilateral triangle over on the side here. So there you have it. That's your equilateral triangle. And I want you to try to figure out, where is it that this height touches that base? Where does the height meet the plane of that equilateral triangle? Well, that's why I drew it bigger, because it will definitely help if I explain it on a surface where you're looking head on. So I've drawn out this equilateral triangle that basically represents this one right there. But now we're looking at it head on. If you draw lines from the vertices to the opposite sides, like that, where they all meet is the center point. And that center point is basically right there. That is where the height will touch that equilateral triangle. Okay? So basically what we need to do is we need to figure out this x, right? This x in this diagram is represented by the green line right there. This one right there. But what about in my diagram here? Where's that x? Well, I could draw it in several places really, but it really is a vertice of the equilateral triangle connected to the center. So it basically would be right here, from here to there. That would be x. Okay? Now we get into the angles of this triangle. This is an equilateral triangle, right? So that means that these are all 60 degrees. So since these lines that I drew cut those angles in half, this is 30 degrees right here. This is a right angle, and therefore this would be 60, because the angles have to add up to 180. And since this is a 60, 30, 90 triangle, we know that the ratio of the sides are 1, 2, and root 3. Correct? This side is going to have a ratio of 1 to 2 for that side, and this side will have a ratio of 3. Now, do we know the length of any of these sides? We do, because the equilateral triangle, remember, has a side length of 2. So from here to here, right here, that's half of the side, correct? So that will basically be 1. So there we go. We have now enough to figure out x. X over 1 in terms of a ratio would be 2 over root 3. This guy right here. So you see how the ratio of the sides of a 30, 60, 90 triangle help us out. And therefore x is just 2 over root 3. So there we go. We've got everything we need to figure out h. Using that triangle and Pythagorean theorem, we have x squared plus h squared is equal to 3 squared. X is 2 over root 3, all squared, plus h squared is equal to 9. And therefore h squared is equal to 9 minus 4 over 3. And if you get a common denominator, you'll get 27 over 3 minus 4 would be 23 over 3. And therefore h would be equal to the square root of 23 over 3. All right? So therefore my total height finally is 3 plus h, and h is 23 over 3, the square root. So let's see, any of our answer choices match that? At first glance, they don't. And this is another example of something like that happening, where you get the correct answer, but it's not one of the answer choices, or it doesn't look like one of the answer choices. So we have to somehow manipulate our answer, not in a way to make it look like it, but we have to basically put it in a different form. And I think what they did is they just rationalized the denominator. So this is 23 root over root 3. So they multiplied top and bottom by root 3, like that. And if you do that, you basically get 3 plus 23 times 3 is 69, which is root 69, and then root 3 times root 3 is 3. So 3 plus 69 over root 69 over 3, so that would be b. So what I really meant to say was that once you get an answer, say, of this form, obviously you can't add 1 to it, or add something. You can't make it a different value than what it is. But you can make it in a different format to make it look exactly like one of the answer choices. And in our case, we did that by rationalizing the denominator. So there you have it. Number 25, the answer is B.